All right, we're back for day 14 of Advent of Code. Here we go. Robots with velocities. Unique feature, they teleport. When they run into the edge, they teleport to the other side. Wrap around the edge. There are in each quadrant after 100 seconds. Okay. Got it. Safety factor. Parse the positions and the velocities. So that'll be this. Oops. Okay. And then Vx, Vy. And then what do we want to do? The wraparound. You 101 tiles wide and 103 tiles. Share the same tile. Okay, that's fine. Let me just try and visually look at this. Yeah, we just want like the coordinates modulo, right? I think so. Plus 100 times Vx mod 101, 102, I guess, because it has to go past the x. Yeah, I think 102 is the correct number. And then, I sure hope so, mod 104. And then we count the number of robots in each quadrant. Okay. Less than 50. Sorry, the Y1 is less than 51, right? Because it's 103. 502 is the even, or 52 is the even row, I think. Or no, 51 is the even row. Sorry. I think that's true. Yeah. Okay. This doesn't actually matter which quadrant is which. All that matters is I'm consistent. Oops, I definitely do not want an else there. I want an else if, because of the tie breaking. Like we don't count it if it's in the middle. And then it's just the product, right? Safety factor is multiplying them together. Yep. Wish I called it something other than quads. It takes a while to type. Okay, there's an answer. Not the right answer. Well, I figured I had some bug here. Is the modulo thing actually correct? I sort of thought it was, but I'm actually not confident. I should also make sure that my, like, getting the minus signs. I'm getting the minus signs here, so that's good. Okay. Seems fine. Let's print quads here. What was the number I got? I got 5331. Wait, this is a very small. In this example, the robots are in space, which is only okay. This makes it a little annoying to test, but fine. Width of this is width of 11 and height of 7, and then x split is going to be width divided by -1 divided by 2. And then y split is the same thing for height. And I think the thing we want to do, oh no, this should just be 101. Shoot, I think. It's that many tiles wide, and 0 is a coordinate. Shoot. I think it should be this number, hopefully. Rank 159, okay. Sad bug. I could have gotten top 100 there. Fuse number seconds must elapse for the robots to display the Easter egg. Most of the robots, oh no. That's rough. Okay. Let's do, like, I guess I just want to print this for a bunch of things. Picture of a Christmas tree. Do I think there's maybe 0 overlaps on the Christmas tree? That seems like a reasonable assumption to make. So let's do this. Let's track the robots. Actually, no. How many robots are there, by the way? 494. Also, it might be the case that they're like adjacent to each other. But for starters, let's do this. 4 steps in range. This is like terribly inefficient. I should not be writing it this way, but it's the fastest way to write it. So that's what I'm going to do. And then steps. And I think what we'll do is I want the number of robots. Maybe I do this. Shoot. S is the wrong thing. I don't know why I called it that. We'll do steps, scene set. Okay, so we're not seeing anything here. Let's do this. Okay, let's actually do. Let me just double check. Okay, they're all 500, so that's fine. So I think we'll do this, and then we'll see when we hit that. Let's pi this. Okay, 8159. Try that. Yes, rank 12. Oh, that's so cheesy. That's so cheesy. I didn't get to see the Christmas tree. Okay, well now I have to see the Christmas tree, right? Like I have to just do it. Okay, so if this happens, then we'll break, and then what we'll do is generate the Christmas tree. Okay, you don't need to keep running. Oh man, I can't believe my cheese strat worked here, but I had to bank on it. Okay, this will be nothing if xy not in scene, otherwise this. For y in range, what was the width? The width here was 103, or sorry, the width is the x coordinate. Yeah, it was 103. For y in range 101, and do that, and then see if we can see a Christmas tree. Oh, what did I do wrong? What did I do wrong? Oh, shoot, this should be this. Fine, I'll run it there, and I'll also run it here. And then hopefully we should see a Christmas tree. Wait, what am I actually doing wrong here? Oh, did I parenthesize this wrong? That I definitely did. I don't normally struggle this hard here. Oh, this was the wrong parenthesization. That's fine. That's fine. Okay, cool. Also run it here. And I should see my Christmas tree this time. I don't need this 0. Christmas tree. Oh, Christmas tree. It's a little cut off on this one, but it should render here a little bit better. Christmas tree. All right. Yeah. Okay. So I should explain that real quick. Especially my cheese strategy, given that that worked so well. I almost feel guilty that the cheese strategy worked, but I don't know how you really do this without the cheese. So yeah, the problem says we're given these coordinates. These are like, what are they? I assume they were robots. I don't actually remember if they are. They are robots. Yeah, so we have x, y coordinates for robots, and we have their velocities, and like the robot just moves in this velocity at each step, and then also they wrap around the corners of their playing field, which is 101 tiles wide and 103 tiles tall. And the first part just asks us like 100 seconds pass. That's 100 steps of like the velocities. What is the product of the number of robots in each quadrant? And quadrant is just like chop out the middle chunk and look at like each quarter. And so it just asks to do that. In part 1, you sort of just do it. The bug I wrote here was that I saw 101 wide, and so one easy way to like figure out the position after some number of steps, like taking into account the wraparound, is just the starting x plus some number of steps times the velocity x modulo the like width. And the mistake I made was I thought it was modulo width plus 1. And the reason why is because I was thinking, oh, we want 0 to be a valid coordinate, we want 101 to be a valid coordinate, and we want 102 to wrap around to 0. This is the thinking that I was going through, and I like to think like this a lot to make sure I don't get off by ones. It did not work out so well for me this time because the mistake I made is that 101 wide does not mean 101 is valid. It means that 100 is valid, and then 101 should wrap around to 0. This gives you exactly 101 valid locations because 0 is also a valid location. So what I really want is modulo 101. And that was a mistake I made at first. So I was doing modulo the wrong thing, and that was why I got a wrong answer. But yeah, that's part 1. It's mostly straightforward. I guess you need to like realize the modulo trick, but it's not too bad after that. Part 2 is now pretty ill-formed, and it says like, at some point, they will form a picture of a Christmas tree. How many seconds must elapse for this to form a Christmas tree? And, you know, like, what does it mean to form a Christmas tree? How do you actually, like, put this into code? I had a few ideas. The first one I had was, oh, I bet it's the case that when they form a Christmas tree, there are no robots overlapping with each other. So why don't I just check to see what the first time step that no robots overlap each other is? So I wrote that, and it spat out a number, and I submitted that number, and that number was correct. So my guess here was exactly right. I keep calling this cheese because nothing in the instructions tells you like the first time step at which all the robots are in unique locations, but that's like a reasonable guess you can make. And it was a guess I made, and it worked out well. I had other ideas too. One other idea was, oh, maybe it's the case that when they form a Christmas tree, most of the robots are adjacent to other robots. So a thing that I thought about computing as well was for each robot, check how many neighbors it has, and sort of like compute the large cluster or the average number of neighbors each robot has, and see when that number gets really large. And whenever it gets really large, that's probably when it forms a Christmas tree. So that was my other idea. Fortunately, the uniqueness thing worked out. I didn't have to implement the other idea. So that was nice. But yeah, that is day 14 of Advent of Code. And then, of course, at the end here, I just wrote this little thing to print out the Christmas tree because I felt like I had to at least look at the Christmas tree and appreciate it. It would be a little sad if I cheesed the solution and then did not actually look at the tree. But yeah, it's a cute little Christmas tree. I guess one thing is that there's like a little particles of snow everywhere. So you probably wouldn't. One other idea I had was like, oh, maybe it's the case that all the robots form like a connected line, like they're all touching each other via some way. So maybe you could do like a connected components algorithm and see when they're all touching. That would not have worked because of these. But maybe it's still fine to like count the number of connected components after some, like count the number of connected components by timestamp or by number of seconds and see when the number gets really low, because surely it does like hit a bottom here. I bet there's lots of interesting plots you could produce with like various heuristics, and I'm sure you would see this pop up in a lot of them. And I bet that's what the intent of this question was, that there's a lot of different ways you can like come to something reasonable. Leaderboard is not quite full yet, but it's about to fill up. But yeah, that worked out well for me for the second part. I definitely choked the first part. I don't know when my first submission was. It was definitely more than a minute before this, because I wasn't locked out. So I was at least 342. 342 would not have made it. I don't know when my actual submission was, but it definitely did feel like one where I could have, maybe I could have gotten a leaderboard if I didn't make this really stupid bug. I've been writing a lot of bugs this year, so really gotta get better at those. But hey, I got, what was that? It was a pretty high rank, 12. I got 12 in part 2, so that's pretty sick. That take me on global again? Oh yeah, I'm on global again. Sick. Cool. Well, yeah, that's all there is for day 14 of Advent of Code, and I will see you tomorrow.